pair of simultaneous equations. Now the harder part here is picking which method you would like to solve it. So you can pick whichever method. So personally, I might use the elimination method on this one. So the way that I chose that, although none of them are the same coefficients, so I will need to play around with them a little bit, I can also see that if I rearrange this, I would probably need to divide by 2 at some point to get x on its own. This is going to give me a fraction, so that's going to be a little bit awkward, and the same sort of thing will happen on the bottom one. So elimination might not be the easiest to use. They're not kind of a y equals ready to plot, and therefore I would probably just use the elimination method. But you could also rearrange them, and then you could plot them on the GDC as well. So if I was using the elimination method, then I might want to multiply this top fraction by the top equation by 3 and the bottom equation by 5 in order to get the y coordinate, the y coefficients the same value. Okay, so multiplying the top one by 3 would give me 6x plus 15y, and that is then equal to minus 36. So minus 36. And then on the second one, I do 7 times 5, so that gives me 35x. And then I have minus 3 times the 5, so minus 15y, and that's equal to minus 5. So I've got equation 1 and equation 2. And now the y coefficients are the same, which means that I can eliminate them. So in this particular question, I'm going to have to add my 2 equations together. Okay, I've got different signs there for the 15 where the coefficients are the same. So I'm going to add together my 2 equations. So 1 plus 2, essentially, got equation 1 plus equation 2, and that gives me 35 plus 6, so 41x. And then I've got minus 15 plus minus 15, or 15 plus minus 15. So that's going to give me 0. And then at the end there, minus 36 minus another 5. So that gives me minus 41. So 41x is equal to minus 41, and therefore x is equal to minus 1. And now I can substitute into either equation, any of the 4, to find my y value. Okay, so I know that my x value is minus 1. So if I take this first one here, for example, 2 lots of minus 1 plus 5y is equal to minus 12. And therefore minus 2 plus 5y equals minus 12. So if I add the 2y to both, to both sides, 5y is equal to minus 10, and therefore y is equal to minus 2. And that would then be my final answer. Y is minus 2 and x is minus 1. Now a different method would have been to perhaps rearrange both of these equations into y equals and use the GDC, in which case you would have 5y is equal to minus 2x minus 12. So y is equal to minus 2/5 of x minus 12 over 5. And you could plot that on your GDC. You could do the same sort of thing for the bottom one. So that would give you 7x plus 1 is equal to 3y. So 7 over 3x plus 1/3 is equal to y. And then with these 2 equations, plot them on the GDC, and then you could find the intersection between them, and you would get the coordinate minus 1, minus 2, and that would work as well. So you've got a choice of methods with that question.